Dear students, today I want to revise the topic waves. At first we can categorize them into two, the mechanical waves and non-mechanical waves. And keep in mind, the mechanical waves means for its propagation medium is necessary. And keep in mind, the medium should got the properties like inertia, elasticity, like that. We can quote the example as water waves, the sound waves, etc. But the non-mechanical waves means the medium is not necessary. That is a very important concept. Electromagnetic waves are the very good example for the non-mechanical waves. In this chapter, depending upon the propagation nature, that waves are divided into two, the transverse waves and the longitudinal waves. The transverse waves means the particles of the medium are vibrating perpendicular to the direction of propagation. And keep in mind, it travels in the form of crust and troughs. And keep in mind, it is possible for solid and not for the liquids and gases. And we can quote some examples. The movement of string of a sitar or violin, the waves are set up on the surface of water. And keep in mind, for liquids, it does not propagate, but we can set up on the surface of liquid. See the longitudinal waves. Particles of the medium vibrate along the direction of propagation of the wave, and it travels in the form of compression and rarefaction, and are possible for solids, liquids and gases. Reason, the volume elasticity is a reason for liquids and gases. We can quote the best examples, our sound waves, and the waves produced by the piston in a air-filled pipe. So these are the fundamental concepts with waves. See some important terms. You are comfortable with the basic terms. What do you mean by the wavelength, the frequency, time period, amplitude, angular frequency and the phase. But here the angular wave number or the propagation constant, you should know it is 2 pi by lambda. The wave number means the number of waves per unit length as 1 by lambda, that is k by 2 pi, are very important concept. While going through the terms, these three words are very important. Especially what is the difference between the particle velocity and the wave velocity. And you should know what I mean by the particle acceleration. Already you know, in a plane progressive wave, all the particles of the medium oscillate simple harmonically about its mean position. So the maximum particle velocity means, as you know, already plus or minus a omega. The acceleration of the particle, simple a omega square. But the wave velocity depends upon the characteristic properties of the medium. Look, the mathematical concept. For the wave equation, you know, y equal to a sine omega t minus kh. The particle velocity means simply it is dy by dt. But the wave velocity is nothing but the frequency into wavelength. But from this relation, it is given by omega by k, omega by k. If you just differentiate y with respect to x, you get the form like this. Del y by del x is equal to minus 1 by v into dy by del by y by del t. And del y by del t, that is called, or we can say dy by dt, that is called the particle velocity. There v is called the wave velocity. And dy by dx, keep in mind, it is a good concept. The slope of the wave at a position x. So these are the very important concepts. Now from this relation, we can move to the linear wave equation, the differential equation. So del square y by del x square equal to 1 by v square into del square y by del t square. How we can represent the plane progressive wave? And keep in mind here the minus sign, meaning that wave is propagating along the positive x direction. If it is moving in the negative x direction, it should be with the plus. So here the y is equal to a sine omega into t minus x by v. You can substitute for omega, and we can write as a is equal to sine into 2 pi by t into small t minus 2 pi by lambda into x. So these are the other terms of our plane progressive wave. And we can go with some problematic situation. Here a progressive wave of frequency 500 Hz is traveling with a velocity of 360 meter per second. How far apart are 2 points 60 degree out of phase? And here we are with this two important concepts. The phase difference between two particles having path difference delta lambda can be related. So keep in mind the 2 pi radian is corresponding to lambda. Then delta phi is for 2 pi by lambda into delta lambda. And again keep in mind the total time period t is for 2 pi radian. Then delta phi is 2 pi by t into delta t. With respect to this question, at first we can find what is the wavelength. Simply the velocity by the frequency, get the value. And here it is pi by 3 radian as the phase difference. So you quote that relation. You get the answer. A good aspect, good concept, keep in mind. A simple question, but it will give the clarity, the basic terms related to a plane progressive wave. It is given in a wave y equal to 5 into sine 100 pi t minus 0.4 pi x, where y and x are in meter, t is in second. Then what is the amplitude, wavelength, frequency, wave velocity, particle velocity, amplitude, etc. So simply we can try to solve that problem. See, given the relation as y is equal to 5 sine so much, but you have to compare it with the general relation as y is equal to a sine omega t minus kx plus 5. So simply that a is nothing but the amplitude 5. So we can find the propagation constant k, 2 pi by lambda. So from that we can find the wavelength. Simple. How we can find the frequency? Here it is omega d. Omega is what? 100 pi. Omega is 2 pi into frequency. So f is good. How we can find velocity? Already it is a very important concept. Omega by k. Simply you can just take 100 pi by 0.4 pi. How we can find the particle velocity? It is a good concept. You just differentiate, or we already know under SHM, the velocity maximum is a omega. So 5 into 100 pi, you get the answer 500. Look, the sound waves are categorized into 3. Our audible one, the 20 to 20 kilohertz in frequency. And keep in mind it is produced by the vocal cords or the musical instruments, etc. Infrasonic waves, the frequency is less than 20 Hz and are produced by the earthquakes, ocean waves, etc. And got the wavelength is greater than 16.6 centimeter. But for the supersonic waves, the frequency is greater than 20 kilohertz with the wavelength less than 1.66 centimeter. And keep in mind the mosquito, dog, bat can give response to such waves. They can sense it. Look, the speed of transverse wave motion on a stretched string, we know V equal to root T by mu. Don't confuse, there M means, here mu means the mass per unit length. and it is the tension. It is a very important aspect. But in a solid body, we can say as V is equal to root of mu by rho, where mu eta by rho, eta is the modulus of rigidity, the rho the density of the material. But for a longitudinal wave means, inside a bar or a wire, keep in mind as V is equal to root y by rho, where y is Young's modulus. But for a liquid and gases, you have to replace that term by the bulk modulus. And if you just compare what is the velocity of sound in air, water and steel, the solid got the maximum velocity, then liquid, then air. So air is with 330 meters per second. The roughly in water 1500, approximately 5000 value in steel. Keep in mind it is not 500, 5000. The Laplace correction to Newton's formula. It is a very important one. The Newton formula, it is a root P by rho, and he said it is an isothermal process. But Laplace proved sound propagates adiabatically, and he gave correction to the equation and can be written as a root of gamma P by rho. The gamma, the ratio specific heat for air, polyatomic, can be treated as 1.41. Look the four important concepts, how the velocity of sound varies with the density through the relation as V is equal to proportional to 1 by root rho. Effect of pressure, we know as gamma, root gamma P by rho, but if we increase the density, the pressure is also increases. So we can say it is independent. It is a very important, but you can replace the pressure by using the ideal gas equation. So it can be written as root of gamma RT by M. So we can say the effect of temperature as V proportional to root T. It is a very important concept. The velocity after a time t is equal to V0 into 1 plus alpha t. And here keep in mind we have to use the degree Celsius scale. Then alpha is called the temperature coefficient of velocity of sound. The temperature difference needed for 1 degree. For 1 degree rise in temperature, how much velocity change happened to the sound? So it is a 0.61. Then what happened to the change in speed because of the humidity? And its density goes on decreasing if the moisture is there, and hence we can say the velocity goes on increasing. So it is a very important concept how the velocity is affected because of the density, pressure, temperature and humidity. Look the next concept. The three important terms are waiting in order to picturize a sound wave. The pitch, the loudness and the quality. Here the pitch means it depends upon the frequency of the wave. Higher the frequency, higher will be the pitch. Loudness, the human ear is sensitive for an extremely large range of intensities. So a logarithmic scale is convenient, and that logarithmic scale is expressed in terms of decibel. So L is equal to 10 log to the base 10 of I by I0. Here I0 is called the minimum intensity. The value is 10 raised to minus 12 watt per meter square. The loudness of normal talks is about 60 decibel. The threshold of pain to ear is 120 decibel. That equation is very, very important. Next one, the quality. Because of quality, we can differentiate two sounds. The quality actually depends upon the shape of the waveforms and the number of overtones. So the quality, it reveals the waveform of the sound. The intensity, energy of waves per unit area per unit time, it is a very important relation as I is equal to 2 pi square n square a square rho into V. Now normally we can say the intensity is proportional to the amplitude square. Their energy density, take the value as I by V. A good concept. We can move with the one problem. A steel wire has a length of 12 meter and a mass of 2.1 kilogram. What should be the tension in the wire so that the speed of transverse wave on the wire is equal to the speed of sound in dry air at 20 degrees Celsius? So here the velocity depends upon as root t by mu. So we can find the value for t is equal to v square mu. The velocity is given simply 343 square inch. That linear density, that is mass by length, you get the answer. In a solid body, see another question. At which temperature the speed of sound in hydrogen will be same as that of the speed of sound in oxygen at 100 degrees Celsius? You can simply use this concept, but keep in mind this relation is for our absolute scale of temperature. But here at the same temperature, so here the velocity proportional, so velocity are taken to be same. So we can say TH2 for hydrogen by oxygen equal to mass of hydrogen by oxygen. So we get the answer 23.2 Kelvin. It should be converted into degrees Celsius. And another good concept, a source of sound emits 200 pi watt power which is uniformly distributed over a sphere of 10 meter radius. What is the loudness of the sound in the surface of the sphere? So you can just use this concept as a 10 log to the base 10 of I by I0. You get the answer as 120 decibel. The principle of superposition, a very important concept. The resultant displacement of a particle at any point of the medium at any time is the vector sum of the displacement caused by the individual waves. We have to discuss the three important. Here in this video we can just discuss the interference and the beats. Then on the coming video we can just give importance to the stunting waves and the Doppler effect. So here the interference is nothing but the phenomenon of intensity variation with respect to the position. That is interference. When two coherent waves of the same frequency propagate in same direction and superimpose on one another, then the intensity of resultant wave becomes maximum and minimum at some points. That is called interference. If we use as y1 equal to a1 sin omega t plus phi 1 and y2 is equal to a2 into sin omega t plus phi by 2, phi 2, if the phase difference is taken as a delta phi, that resultant amplitude can be calculated by the formula, the very important one, as a root of a1 square plus a2 square plus 2a1a2 cos delta phi, and the intensity I can be treated as I1 plus I2 plus 2 root I1 root I2 cos delta phi. You should know what I mean by the constructive interference and destructive interference. The two waves, in the sense they are with the same phase or with a constant phase difference, and we can say construction will happen. Their intensity got the value of maximum, but at the same time for the destructive interference, minima will happen. So there should be a phase difference of pi of the order. Here of the order of 0 or 2 pi. So look the path differences between the two cases. We can move with one question. The two sound waves are given. The resultant amplitude at a place where. So you just to know what is the phase difference. It is theta. Then you can just substitute. See. Root of a1 square plus a2 square plus 2a1a2 cos phi. They are with a phase difference of pi by 2. Simple answer. If the ratio of amplitude of two waves is 4:3, then the ratio of maximum and minimum intensity will be, keep in mind as I maximum is a1 plus a2 the whole square by I minimum a1 minus a2 the whole square. But it is given as a1 by a2. So we can just take a2 outside and you get the form like this one. So answer becomes simple. Beats, a very important concept. When two sound waves of the same amplitude are traveling in same direction with a different frequency superimpose, then the resultant intensity varies periodically with time. That is called beats. Look, if it is y1 is a sine omega 1 as 2 pi n1 t, and y2 a sine 2 pi n2 t. Then what happened for superposition? You get a relation like this one. So that is a very important concept. What is the resultant wave? And that is a very important concept. And you get the concept, the frequency of the resultant wave. Look here. n1 plus n2 by 2. The frequency of the amplitude, that is n1 minus n2 by 2. And the beat frequency is what? That is n1 minus n2. This is the very important with respect to our problematic situations. The bit frequency as n1 minus n2. And the bit time period we can say as 1 by n1 minus n2. A good aspect. See, we are with the two good questions. A tuning fork A produces 4 beats per second with another tuning fork B of frequency 320 Hz. On filing, the fork A, 4 beats per second are again heard. The frequency of fork A after filing is. Look, the concept, it is very, very important. We can, based on the beat concept, we can say Na minus Np is equal to X, or Np minus Na is equal to X. But here it is one concept is there. Even after filing, that beat frequencies remains unchanged. So which one is the correct response? N is filing means the mass is decreased means the frequency goes on increasing. So that means that relevant concept becomes the second relation. So you get 360. But the question, the frequency after filing is asked, which must be greater than 316. Good? Good? Yes. So extra. So that should be 324 here. So that is the answer. A very good question. The 25 tuning forks are arranged in series in the order of decrease in frequency. Any two successive forks produce 3 beats per second. The frequency of the first tuning fork is the octave of the last fork. The frequency of the 21st fork is, and keep in mind, the adjacent are difference with the 3 frequencies. So here if it is 2n, why it is 2n? It is given the octave of the last. So it is taken as a 2n. So the last one is n. Good. So here it is 2n. So the next one is with the difference of 3. So 2n minus 3. Next one 2n minus 6. So how we can write for the 21st one? 2n minus. Yes, 1 less 20 into 3. So the last one 2n minus 24 into 3 is equal to n. By using that one you can just find the value for 72. We get the value n as 72. Then the frequency of the 21st tuning fork is, we get the answer 84. A good question. So students, you can wait for the next video. In that we can just discuss the slanting waves, and especially the slanting waves in stretched string, open pipe, closed pipe, and resonance column, and also the Doppler effect. A very important concept are waiting. So try to do the maximum MCQs, then you can get the maximum rank in the coming NEET, JEE, KEAM entrance exams.